This is a lesson on the modern atom, modern model of the atom. I will go back. I don't know if I can edit this or not. On the last lesson, there should have been the nuclear atom with Rutherford This is a lesson on the modern model of the atom. The modern model contains a nucleus, which we now know through other experiments and stuff to contain protons and neutrons, which are neutral, which may be very difficult to detect. This nucleus is very, very, very small and very, 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 very dense. What is about the atom that makes the atom is the number of protons. So protons determine the type of atom, the element. If you change the number of protons, you change the number, change the type of element that you have. Isotope has a varying number of neutrons. You have a few more, a few less neutrons than the average. And then electrons, what the electrons do is they determine the chemical properties. Whether you got full shells, where you had full shells is inert, one fewer, one extra you don't have. So, for example, you can have isotope notation of this. This would mean this is the number of protons. This is the number of protons and neutrons. And this up here, if there was one, is the charge. So if you have 11 protons, neutrons, and electrons, you have 11 protons. If you subtract 23 minus 11, you get 12, and that's the number of neutrons because 11 plus 12 is 23. And the number of electrons, since it's neutral, the protons and electrons have to be 0, so that is 11. 11 positive charges and 11 negative charges cancel out. If it was a charged ion, sodium is +1, again you'd have 11 protons, because it's still sodium and the number of protons make the element. You'd have 12 neutrons. You still subtract those. But now, how many electrons do you have? Well, you got extra protons, so it would be 10. Because 10 positives minus 10 negatives makes a +1. So another way you can do this is look at the protons minus the charge. So if it's 11 minus 1, you get 10. If it was a -2 charge, then it would be 11 minus a -2 would be -13, and that would make 13 electrons. And that would make sense because you now have a negative charge, which means you have a surplus of electrons. General basic concept between molecules and ions. Covalent compounds share electrons. In general, this is broad, wide strokes. There are a bunch of stuff we're going to learn later on this year about that. But overall, covalent compounds share electrons to form molecules. You can have molecular formulas, H2O, you have Lewis dot diagrams, which we're going to go over again this year. You can have space filling or ball and stick models. You have lots of different ways to represent these. Space filling is usually on a computer, and it's sort of a realistic looking of what the water molecule would look like, and you can do it ball and stick. Ionic compounds give or take or transfer electrons. So they transfer electrons to form ionic solids. You could have ionic gas occasionally, but they transfer electrons as a rule, and you form a solid as a rule. The substance that gives off the electron becomes positive, and that's a cation. And the thing that gains electrons is the anion, which means it's negatively charged. Periodic table, really quickly. Metals are on the left 2/3 of the periodic table. They lose electrons, they form cations. In general, their properties are ductile, malleable, conductive to electricity and heat, and lustrous, which means they can be polished and form a shiny surface. Nonmetals are on the right, upper right hand in general. They gain electrons. When they gain electrons, they form anions, and typically, many times they are gases, but not always. But they are dull, they insulate, they don't conduct electricity. They tend to be gases, not always. And dull. If they do make a solid, they're dull, shaped like a brick of charcoal. Groups and families are vertical, periods, or horizontal. Checking my notes. Yes, that's all I have, and that's the end of this lesson.